In this section of communication systems, we're going to be talking about communicating with sound. Our verbal sound can be used in a lot of different ways, and especially when we take that verbal sound and transfer it through some type of technology system in order to communicate with one another. So when talking about sound, first of all, we have to look at what is sound and how do we actually hear sound. So first of all, as a definition, sound is a rapid disturbance of a substance or a medium. And the key component here is the rapid disturbance. So for example, I can take my hand and move it, but as I move it smoothly, you don't hear any sound. There's no rapid disturbance. But if I take my hands and I clap, you hear a sound because that creates a rapid disturbance in the air. And that rapid disturbance is picked up within our ear. And that's how we hear. So within our ears, we have first of all the eardrum, which is located right about here, which is a thin membrane that vibrates with the sound. It works very much like a drum, just as the surface of the drum vibrates to make the sound. So that's the same way that the thin membrane in our ear works. And then that vibration or the sound is transferred through three bones, the hammer, anvil, and stirrup, and then is passed along to the cochlea, which is located right about here. And the cochlea is a tube filled with fluid, and within that tube there are about 15,000 different nerve fibers. So as those vibrations, the vibrations are going through the cochlea, the nerve fibers pick up that information and then send it on to the brain, then allowing us to process that information and understand the sound. As humans, we hear about 30 to 20,000 hertz, or vibrations per second. And we measure that in hertz, Hz, and which hertz is the measurement of frequency. Frequency being the number of waves that pass a given point in a second. So as we make that rapid disturbance in the air, it creates a wave in the air, and that wave has a curve, a standard sine wave, and it has a frequency to it. And that frequency is going to be dependent upon how often those waves go through, how short or long or tall those waves happen to be. And we measure those in hertz. And so as humans, we hear about 30 to 20,000 vibrations per second. And so just like as we talked about before, there are colors that we can't see, there are sounds that we can't hear, but there are other animals, for example like a dog, that can hear a greater range, and so they can hear different frequencies of information out there. And all of these sounds we take and we measure them in decibels, which is a measurement of the loudness of sound. So let's look here at a couple charts on decibels. Again, it's the measurement of the loudness of sound. And OSHA has identified appropriate noise exposure limits depending on the type of sound. So first of all, we have to look at how loud is the sound, what are the decibels of the sound. And so for example, on the chart down over here, you can see that busy city traffic is about 85 decibels. Moving up to a chainsaw is going to run at about 110 decibels, to a jackhammer at 120 decibels. So we have the loudness of it, but then in terms of exposure limits, that takes into play the length of time. So it's not just how loud is it, but it's also how long are you exposed to that loudness or that decibel of sound. So you can see up here on this chart, the OSHA has identified that about 90 decibels, it's appropriate to be exposed to that for about 8 hours. So again, busy city traffic or kind of a noisy office, that's okay, exposure level for 8 hours a day. But then as you move up in sound, let's say we get all the way up to 105 decibels, that we're looking at for only an hour, which looking at a chart, maybe that's, for example, something as loud as a chainsaw. But then when we get up into the range of 115, 120, something like a jackhammer, we should only be exposed to that for 15 minutes or less. If not, if we're going to be exposed to that in longer times, then we need to use some type of ear protection. And as applied technology students in a variety of different areas in our different work environments, whether it be a wood lab, a construction site, of different manufacturing companies, it's very likely that the common sound levels in that environment are up in that 110 to 120 range. And so you really need to be careful with that, and in many cases we should be wearing ear protection if we're going to be exposed to those things. And even on a riding lawnmower, where we're going to spend a couple hours on a riding lawnmower, then we certainly should have some ear protection, because that is certainly up in the range of the 100 to 110 sound levels. Okay, in terms of sound, we have other sounds such as ultrasound, which are sounds above the frequency range that we hear as humans. And so, for example, a bat uses ultrasound to communicate. It sends out an echo, sound waves that bounce back, to determine the distances that it can travel, or to be able to navigate through the different environments. And so we don't, as humans, we don't hear that sound from the bats, but they constantly send that sound and it comes back to them in the form of an echo. Sonar is another form of ultrasound, which stands for sound, navigation, and ranging, which sends out ultrasonic waves to determine different distances. We're familiar with sonar. Ships, airplanes, and those types of things use sonar to determine different ranges. So a ship might use sonar to determine the depth or the different components on the water floor, ocean floor, wherever they might be. There are all kinds of different other applications of ultrasonic sound in business. We're all familiar with an ultrasound in the medical community, where if we need to be able to see what's going on the inside of our belly, let's say with our kidney, our liver, that we may have an ultrasound where they send out sound frequencies. Again, we don't hear anything, but it sends out a sound frequency and comes back and can identify the different shapes and components of our internal organs. This is commonly used for ladies who are pregnant, that they will go in and have an ultrasound of the baby to identify the condition of the baby and how well it's growing and all of those types of things. There are lots of other components as well. Even dentists will use ultrasound to clean teeth. And so there's all kinds of different ways that we can use ultrasound in business. And again, all of those things are simply sound waves that are sent out that do a job for us, that do something effective for us, that go beyond what we can hear. So this comes into play when looking at the different technology systems into the Electro Magnet, which is a critical invention that is kind of the foundation of many of our communication technologies that we use today. So it was used, electromagnetic was used in motors, telephones, and radios. In the telephone, it's used to change electrical signal to voice, which we're going to talk about more here in a minute. So this was discovered by Hans Christian Ørsted, who found that a magnetic field was created around a wire carrying current. So we had the invention of electricity and the understanding of electrons traveling through a wire, creating a current. But then Mr. Ørsted found that as electrons were traveling through a conductor, a wire, that a magnetic field was created, thus leading to the development of the electromagnet. And the electromagnet is simply a coil of wire with an iron core. That coil of wire is called the solenoid, with an iron core. And as the current increases, as it goes through the conductor, the magnetic intensity increases. And as normal, when you discover something, you find something, a new, whatever it might be, you name it after yourself. And so the intensity, the magnetic intensity, is measured in Ørsteds, named after Hans Ørsted, who discovered that the component of the wire. So here you can see kind of an example of electromagnet. And Michael Faraday then took the information that Mr. Ørsted developed and kind of discovered the opposite, in that a magnet could be used actually to create an electric current. So Mr. Ørsted found that a magnetic field was created about the wire. Michael Faraday took it the other way and found how we could use a magnet to actually create an electric current. We call this magnetic induction. And in this case, a magnet is moved near a coil of wire, and because as that magnet is moved, it produces a electric current in the wire. And so this was used in a lot of different ways. One of the first ways was used by Samuel Morse in 1835 to create the telegraph. And the telegraph system consists of a key and a sounder in two different locations that are connected by a wire. So at one end we have the key, and at the other end we have the sounder, and those are connected with a wire. And when the key is pressed, it sends a current that flows through the wire, and at the other end that magnetizes the electromagnet at the receiver. And when that happens at the receiver end, then the sounder is moved, that current goes through and it tracks the sounder, and that sounder creates a noise, thus allowing us to be able to communicate. So as part of developing the telegraph, Mr. Morse also developed Morse Code, the system of dots and dashes to communicate over long distances, therefore allowing somebody with the key on one end to be able to push the button, which creates off and on currents, and at the other end that is recorded or listened to, and through the form of Morse Code we could send messages. So then Mr. Morse, along the same time, then also invested in and developed basically the wires across various networks to create the telegraph system. Well, that technology was then further built upon by Mr. Graham Bell when he invented the telephone. Kind of the same idea here is that we had a transmitter on one end and a receiver on the other end, and the transmitter has a diaphragm that vibrates at the same frequency of your voice. And as that vibration occurs, it creates an electric current that is sent through the wire. So the sound vibration is transduced into electric current from the one end, which then goes to the other end, which has a diaphragm and electromagnet. As the current passes through the electromagnet, it causes the diaphragm to vibrate, creating sounds. So really it's very similar to the telegraph, but instead of transferring dots and dashes, we're actually transferring audio sound. So our voice creates, on the microphone end, it creates vibrations, which then that electric current is sent through the lines to the other end, where those vibrations affect a speaker, which then creates the sound. This component is developed, and the system was all developed and using a switchboard, which is a large board where you can make connections to make phone calls from different locations. So originally it was all done by hand, where you had a switchboard operator or the operator who would actually make that connection. So they would have a whole board of all the different, let's say, the houses in the town. And so if house A wanted to call house B, the operator would use basically a wire and connect A to B so that electric current could flow from one end to the other. Nowadays, that's all done by computer. It's all becoming electronic and done by computer, which obviously happens much faster and more efficient. The old rotary dial phones used different tone, or excuse me, when we did the different rotary dials, you had different numbers that would put together a different tone, if you will. And now that's even taken further with the dual tone frequency, which now with the phone, as you push one of the buttons, it has a specific tone, or actually two tones for confirmation that creates each sound, which then creates that connection. Alright, so that's a quick overview, understand of sound and how we hear and those types of things, but that really is kind of the foundation to how we're able to use things such as, which led to the development of the telegraph and the telephone, which nowadays can be taken into a variety of different technologies and different systems that allow us to communicate through sound.